Thank you, Anna. Very nice presentation and quick introduction. That was cool. I'd like to share my webcam. Let me see if that works. And then you should see a blurry picture of me in the cave. Here we go. Now it's getting a little bit more crisp. That's Fabian. Fabian, Dembski, and myself. We are here at the HLRS in our virtual environment. Behind me, you actually see a tsunami visualization, but I will skip this until later in the presentation. And in the meantime, I would like to show you my slides on my second laptop. If you would be so kind to share my screen. Here we go. Screen sharing. Here we go. Yes, we're here in behalf of two projects, Hidalgo and Cheese. And we use the same tools, as Anna already said, Covise and Wissel for those two projects. I think I'll skip the HLR. Well, perhaps two words about this. This is our current system, Hawk, that we just installed and which is in production now, a very nice supercomputer. And we use the system to do parallel visualization, and you'll hear more about this, about Wissel and parallel visualization and interactive simulations by Dennis later. In my presentation, I want to show you digital twins. You have seen visualizations of airflow inside a city model by Anna already, but we want to make these visualizations a little bit more lively and more accessible to people. So the goal is to create a participatory environment where people can experience a city as in real life, but are free to explore new variations, explore effects of a pandemic or of bad weather inside a city without being harmed. And so these digital twins allow you to study traffic in a city, what would happen if scenarios. So for instance, we are working on our campus and want to make it car-free. And you can try to find out what that would mean for your campus or for your city quarter if you drastically change mobility inside such an environment. And people want to be informed, not only decision makers, but also the general public. And to allow this, we create virtual twins of these cities that you can walk through and experience. And one key point of it is that it's not only one model, one data set, one simulation that you want to look at, but it's always different simulations that you want to combine. The picture you've just seen is from a project we have in Hildesheim, a smaller town here in Germany, and we integrated a BIM model in this digital twin. BIM stands for Building Information Modeling. That's sort of the new 3D CAD systems, which allow you to specify more than just building geometries, but also material information, and allow you to do simulations in these buildings. And we can integrate those BIM models in the virtual world. Another example is a data set for the city of Herrenberg, and we'll have a look at this in 3D right now. So what I will do is I will walk over to our cluster desktop, and let me see if I find this real quick. 39. And I'm now loading this data set. I need some 3D glasses and a 3D mouse. And then we can dive into this virtual world. So if you zoom up the video picture, the video stream, you will soon see the data set appear in our 3D environment. Come on. I hope it wasn't tested. This is a live demo. So everything that can happen during a live demo will happen. So be advised. But it looks sort of still progressing. Come on. Here we go. So now I'm standing inside a model of the city of Herrenberg, and I can walk around in this city. Yep. Yeah. And yes, without a pandemic, we would be multiple people in the cave at the same time, so that we can collaborate and discuss what we see here on the screen. So I will fly up to give you a little overview of this city model. You see a standard LOD2 or 2.5. That's buildings with roof shapes, and but otherwise just sort of block buildings of the whole city of Herrenberg. You see a huge landscape model at high resolution, 1 meter resolution, which gets paged into this visualization while we navigate through the system, much like Google Earth would do. But you also see more high resolution parts of the data set, like this new building project that's a mall combined with some kindergarten and some office space and some retirement home, and also a little river that flows around down here. So you can walk into this data set and experience how that would look like if that river would be opened as it is visualized here. You also see some tables and chairs for a little cafe out here, and so on. So this is just some standard city model visualization, but we also have simulations in here. So streamlines coming in from a Covise visualization of the airflow. The simulation was done using open foam. You also see an isosurface down here showing the distribution of particulate matter coming from exhausts from cars traveling on this street. You also have lines. I will scale down that model. So you can walk through this town at scale 1 to 1, but you can also grab it, pick it up, take it in your hand like a model size data set, and work with it that way. And you see some traces of students and scholars that walk through the city. And Fabian, could you scale up the signs a little for me?
Yeah, I'm trying to.
And we also did a network analysis of the street network. We also included traffic simulation in here, and all of this can be visualized together, right? What I perhaps also want to show you real quick is the marketplace. So this is the standard way a 3D city model would look like, the gray buildings, but we can also, oops, that was wrong. Let me switch to a viewpoint real quick. Fast run. Come on. Marketplace. Here we go. So this is the marketplace. And kannst du mal das 3D-Stadtmodell ausblenden? Das ist die Punktwolke. Nee, die Punktwolke. Nee, die hast du gerade wieder ausgemacht. Here we go. So this is the point cloud that we took. We went there with the scanner and took a point cloud from that marketplace, and this gives you a much more detailed visualization of how it looks like over there and people that know this place would recognize it immediately, and you can do some more detailed planning in those areas. So let's switch back to the slides. Yeah, another application area where we use these digital twins would be a project we have in Vorbach. Vorbach is a small little town in the northern part of the Black Forest. That's about half an hour from here. It's a mountainous area, and they have water power plants over there. And we accompany the project of them trying to renew this power plant. And yeah, again, the planners want to have access to that information and do detailed planning in 3D. But also the public wants to be involved and wants to have access to those simulations that we do. And simulations in this case would be flooding simulations if a dam break happens, or construction noise simulations, or for the engineers, we would do optimizations of the water flow through the power station. And all of this is supposed to be accessible for all of these users. Let me try to load this real quick. Mastercard. Oh, hard to find this data set. But here we go. I found it.
Well, one important part is the participation processes, to enhance participatory processes in the context of the energy transition. That's quite a big topic in Germany, because you maybe heard about the term "not in my backyard." So people like to switch to renewable energy, but they are not aware of the measures which are necessary to reach these goals. Well, in this case, with the project in Vorbach, people were involved from the first moment on, and this project is going to be realized, one of the few large-scale projects. So Uwe is already in Vorbach, and well, let's switch to a mode you can see better. So you can switch to the video now.
Yes, so we've got a 3D visualization as we discussed. It's nice and immersive and 3D, but for the videotaping, we switch back to 2D mode so that you have a more crisp image on the video. Anyway, what you see here again is a digital twin of that area, a little valley with a river down there and some mountains. We can fly over these mountains. There you see a big water storage with an artificial dam that holds back the water. And now how would a new power station be implemented in here? We can see that if we dive down into the mountain underground, and here you see a huge set of tunnels, ducts and tunnels, and again a BIM model, a 3D CAD model of a power plant building. This is rather detailed, so you can step into it down until individual rooms. They have all doors and stairs and handrails and whatnot, and also the whole machinery is in here, like these two turbines. There's a much bigger turbine further left in the building. Let me run through here real quick.
Video pauses and chatters a bit, but yeah, I hope you're getting a good impression of it.
Yeah. So the key point to take away in here is that you can combine many different data sets. Like here, these rods in the mountain show you borehole scans. You can do seismic simulations. You can do, again, airflow, water flow simulations for flooding. And let's switch to some construction noise simulations. Like here, this is the situation in the first year of construction, where there will be a lot of noise down in that valley. And it also shows you that some of the neighbor buildings, these here are neighboring homes down there, and they are within the purple zone, which is above threshold. So you have to talk to these, give them new windows or new roofs or compensation or whatever. But you can also show that, for instance, in year 2 of the construction, noise will be very, very limited. It'll be restricted to basically street noise. If you compare this construction, the street noise introduced by the construction and a simulation of the street noise just without any construction, you hardly see any difference because there's a lot of traffic on that little road anyway. So this is a nice way to convince people, well, the effect of that construction will not be that important for us, right? Or for some of them, especially the 3 buildings over there, it will be important, but they will be heard. And yeah. So again, this is the same software system that Anna did show you. You can do these kinds of visualizations easily with any of your data that you have, as long as it is 3D. Yeah, how to do that? I think if I still have a couple of minutes, if we'll go back to the slides. Yeah, here we go. I will give you a very quick introduction how you do these visualizations within Covise. Again, a live presentation. Du kannst mal gucken, ob das an unserer Kamera liegt. Nee, Kamera tut, hat schon sich erledigt. So let's give you a quick introduction how to easily visualize data with Covise. So I start the Covise environment on my laptop here on Windows. There's a downloader available. If you go to www.hlrs.de/Covise, you can click on support and download, and you will get a simple installer for Windows. For Linux, there are also instructions how to build Covise quite easily. And then you start Covise and you end up with that map editor. Let me start a quick visualization of artificially generated data. So there's a generate data module that I can drag over to my canvas. And let's create a cutting surface through that data set. In order to do that, I can pick a cutting surface module from the toolbar up here. And yes, let's just connect those. These modules have ports. You see those little squares. And if you hover over them, you get a hint on which ports you can connect, which data types match and which not. So here the left one only has one possibility. That's the grid output port of that generate data module. If you hover over port, it also gives you a tooltip telling you what type of data that is. It's a grid, and there's no data yet, so it doesn't know the exact data type. The second one is some scalar data that we have. Could be pressure or temperature or something similar. And we can connect it to the second port of our cutting surface module. So you always need a computational mesh and some data, and then this cutting surface module can do its work. To run this visualization, you can press this execute pipeline button up the left, and all of a sudden those ports will be highlighted, the ones at least which have data. So here you see it's a uniform grid that was generated here, and some scalar data, float data is available here. And here should be our cutting surface. Now let's color this cutting surface. Just the surface is a little lame, so we want to have colors on that surface, and we combine those colors with the geometry with a collect module, and then we route everything into a render module. This time it's not the thermal renderer that creates the web visualization, but this here is our interactive rendering for the cave and for the desktop. So we can just connect our cutting surface to this rendering and now execute either the whole pipeline again or just the modules that need to do some work, like the colors module and the collect. And so I just double click the colors module to run this visualization, the rest of the visualization. And now we do have the results here in our render window, which is a cut through a data set, and that's it. So it's that easy. If you want to look at the read modules that we have, you see a couple of well-known data formats that you might recognize, like an ANSYS reader, CFX, general CSV, Nsight, Fluent, NetCDF. The Tsunami Reader is the module that I developed for cheese to read in Tsunami results of that in NetCDF format. And there's a button more that gives you many more read modules. So if you want to browse through them, you will probably find some data formats, again, that you recognize and that might be helpful. And if your simulation code is not visible here, you can always easily write some read module to extend Covise to read your specific data type. Read VTK should perhaps also be mentioned because a lot of you use ParaView, so it's also easy to switch from ParaView to Covise if you need a virtual reality visualization. Perhaps I'll finish off this visualization with a show grid module just to make it a little more nice to see. The rest of the computational grid, there are parameters in each module behind those little books, and we can select 3 sides of the mesh to be rendered, and this gives you an idea of the computational mesh, a very simple one in this case. And I can also show you the interaction possibilities in your virtual environment, which, for example, would be, in this case, the cutting surface, and you can grab this interactor on the cutting surface and move it about and thus cut through different locations in that data set. So again, it's easy to use. I would recommend to everyone to give it a try. If you want to use Covise or Vissel, give us a call. We can give you web tutorials, individual web tutorials if you're having issues with it. If you need information on how to create a digital twin, how to include other types of data sets like huge terrains or interactive simulations of traffic or whatever you think you need, volume rendering, particle, point cloud rendering, everything is possible. Just don't hesitate, give us a call and we try to help. And now I think it would be a good time for Dennis to follow on and give you an introduction to Wissel, which is very similar to Covise. It does share all of the concepts, like the different modules with their parameters, and most important, it does share the whole rendering system. So once you've done a visualization with Covise, you might find it also easy to switch to Wissel, but use the advantages that Dennis will show you.
Okay. Well, thank you very much, Uwe Wössner, for this interesting presentation of the cave and visualization tool. Maybe we have time for some questions if some participants raise their hands or have.
Those of you who do not want to take the break, I will just continue a little. I just didn't want to take too much time of your time, but if you want to enlarge the visualization window, I will show you a little bit of Stuttgart. Let me show you the Marienplatz. It is a little place in Stuttgart that we are working on, and Fabian is just carrying in our new interface to that visualization. Oh, come on, interface. It's a skateboard, and behind him you see a virtual data set of the Marienplatz. And what we can do now, do you want to show, Fabian?
Oh, yeah, I could.
Ich habe schon umgestellt.
I just need the glasses.
Ah, here we go.
Thank you very much. I'll try my best. I'm not a good skater.
So yes, again, we have a virtual model of the whole city of Stuttgart. Right now, this is just a smaller part, a little place. And in this project, we want to improve the walkability and cycling around on that place. There's a big, an important bike route that runs right over that place. And but the situation is rather difficult to cross this place without interference between cyclists and pedestrians. And Fabian is giving its best, but he's having a hard time jumping down these steps. Ah, here we go, and up again. Perfect. So just to show you that we are also having fun, let's switch back to some more serious visualization of the city of Stuttgart.
Could you explain quickly how the movement is doing with the skateboard? Is you have to lean to the sides, then
if you lean left and right, you steer left and right, and the velocity is an issue because you cannot push. So what we did is we just implemented a leaning forward, which will accelerate, and leaning backwards will decelerate. So it is quite intuitive to use, and if you can skate, which we can't, then it should also be easy to do. I'm pointing the camera over to our desktop to show you how the desktop for this visualization looks like. This here, again, it leans into the next presentation, which will be on Wissel. It looks very similar. You have a network of modules which are connected through lines. And if you run this visualization, each of these modules is computing its tasks. This time, this is Wissel, so all of these modules are running in parallel. on our cluster. And down on the bottom of that pipeline, I can point to it with my finger, that's better. There's the rendering module cover, which is the same as in Covise, and it allows you to render your digital twins in a virtual environment or on the desktop. Yeah, this time, this is the whole city of Stuttgart, including visualizations of the airflow in the city. The airflow was simulated by two institutions. One of them is Hidalgo. In the Hidalgo project, we have the air pollution scenario, which creates simulations of the airflow inside cities. Where are my 3D glasses? Ah, thank you. And I can show you the results of these simulations in this huge city model. Again, as I said, we include many different types of simulations. For instance, a traffic simulation simulating pedestrian traffic flow on our campus. You've seen a shuttle passing by on the street. There are not many cars on that street because we, as I said, we want to create a car-free campus. If I fly up, you see all of our campus. The HLRS building is down below here. And yeah, this actually, you just tell me when to stop when Dennis is ready for his presentation.
I am.
Speed up real quick and go downtown. Again, this is a huge data set representing all of Stuttgart and 50 kilometers around Stuttgart. And downtown, we can now have a look at simulation results as well, coming from that missile simulation. All I need to do is I need to grab a tablet. So if you have a look at the video, you should see that. And I hope that my fingers are not too big. But here, you see an animation of a simulation. I'll just stop the animation of different time steps of an in-stationary simulation, simulating the airflow around that city model. You see how that isosurface nicely snags around the different buildings in the city. We can also visualize some streamlines in that area, and I can scale things down to a model size. And so it's basically very similar to what Anna presented on the web page, but here it is interactive. You can interact with the visualizations. For instance, I can pick the Visual menu, and this will give me a particle tracer interface and allows me to directly interact with that streamline simulation module. And I can now grab it and create streamlines, compute streamlines anywhere in that data set I'm interested in. So this is Hidalgo data, and we can also switch to a different model showing NO2 as well.
But I think we have to kick you out, Uwe.
Okay.
I think it's time to give the floor to Dennis.
To Dennis. Perfect.
Thank you
had
very
your
much.